Hey folks, thought we'd look at a homework problem for parametric equations. This was a problem where you were asked to find horizontal and vertical tangents. So in the Larson-Hostetler text, this is section 10.3, number 34. Now the directions for this problem stated something along the lines of find all points of horizontal and vertical tangency to the curve given by x equals cosine theta, y equals 2 sine 2 theta. So here are parameters theta. And so starting off, we know in parametric equations, with parametric equations, we know dy dx is dy d theta over dx d theta. If the parameter were t, instead of theta, if it were t, we would have dy dt over dx dt. But now when it comes to horizontal and vertical tangencies, to get a horizontal tangency, we're going to try to determine where does dy d theta equal 0. Where does the numerator here? Where does dy d theta equal 0? But dx d theta cannot be 0. So if we find a value of theta where dy d theta is 0, we have to make sure that for that same value of theta, dx d theta is not 0. Because 0 over 0, who the hell knows what that is? Likewise, for a vertical tangency, dx d theta equaling 0, dx d theta equaling 0, and dy d theta not 0 will give us a vertical tangency. So any value of theta where dx d theta is 0, dy d theta not 0, we have a vertical tangency. So I guess like a short summary here would be if you find a value of theta where dy d theta is 0 and dx d theta is 0, we have no idea what is going on there. Next up, well, I guess we should probably start doing a little calculus here. Well, since x equals cosine theta, dx d theta is negative sine theta. So we take our dx d theta is equal to negative sine theta, set it equal to 0. So set it equal to 0 and multiply both sides by negative 1. That just gives us this equation. Pretty easy trig equation to solve. Purely from the unit circle, sine theta equals 0 at theta equals 0 or pi. So that's where dx d theta is equal to 0. Keep in mind, these are values of theta where we might find a vertical tangent. We need to know if these values of theta also make dy d theta equal 0. Because if it does, we don't know what's going on. So one more time, these are the values of theta where we might find a vertical tangent. We need to get the values of theta where dy d theta equals 0, and we should probably do that pretty quickly. In fact, that's our next task. So remembering that y was equal to 2 sine 2 theta, dy d theta is equal to 4 cosine 2 theta. And same process, set it equal to 0. So we have 0 equals 4 cosine 2 theta. And then I divide both sides by 4 to get 0 equals cosine 2 theta. It's a very friendly trig equation to solve. There are many ways to solve this trig equation. I am going to opt to, just kind of review double angle identities. I'm solving it that way so we can have a reminder on double angle identities. And so you need to recall that the double angle identities for cosine, so double angle identities for cosine 2 theta are, remember there were 3 different flavors for cosine 2 theta. You could either have cosine squared theta minus sine squared theta, or cosine 2 theta equals 2 cosine squared theta minus 1, or cosine 2 theta equals 1 minus 2 sine squared theta. Out of these 3 different flavors, it really doesn't matter which one I use, Uh, Really, I would narrow it down to using 2 or 3 to substitute over here for cosine 2 theta because there's only one trig function involved. And then between these two, it doesn't matter which one I use, but I opt to use the second one. So I'm going to put 2 cosine squared theta minus 1. That's a double angle identity for cosine 2 theta. And now to continue solving, I just simply add 1 to both sides of the equation and then divide both sides of the equation by 2 to give me a 1/2 equals a cosine squared theta. Then we take the square root of both sides and we have cosine theta equals plus or minus 1 over the square root 2. And if we go ahead and rationalize that, we get plus or minus square root 2 over 2. It comes back to the unit circle. X coordinate, because we're dealing with the trig function cosine. So that's an x coordinate off the unit circle. And so for what values of theta does cosine theta equal plus or minus square root 2 over 2? Those values of theta are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So we now have determined the values. We now have determined where dy d theta is equal to 0. Those values of theta, that's where dy d theta is equal to 0. And we determined where dx d theta was equal to 0. Dx d theta was 0 at 0 and pi. So notice none of these values of theta, where dy d theta is 0, none of those values also make dx d theta equal 0. Likewise, none of the values where dx d theta is 0, 0 or pi, are over here where dy d theta is equal to 0. So what that means is these are the values of theta where we have horizontal tangents. These are the values of theta where we have vertical tangents. So it seems easy enough. We found where the values of theta where we have horizontal tangents and the values of theta where we have vertical tangents. But you were asked to find points of tangency. So points of tangency, they come of the form x, y. We want to see ordered pairs, x, y. We know the value of theta that they occur, but we don't know the points where they occur. This isn't too bad. So for the horizontal points of tangency, we're simply going to take these values of theta. We're going to toss them back into the original parametric equations we were given. Remember, we were given x equals, what were we given? X equals cosine theta and y equals 2 sine theta. So if we toss pi over 4 in for cosine theta, we get the x coordinate as square root 2 over 2. And we toss pi over 4 into theta for the parametric equation part that says y equals 2 sine theta, and we get y equals 2. So you're just simply substituting the theta value back into the thetas in your parametric equations to give you the x coordinate and the y coordinate, and that's what the point is as an ordered pair, square root 2 over 2. Likewise, if you toss 3 pi over 4 in for theta, you will get x as negative square root 2 over 2, and y is negative 2. So that gives you another point where there's a horizontal tangency. Moving on, if we toss 5 pi over 4 back into the parametric equations for theta, we get x as negative square root 2 over 2, y is 2. So that gives us a third point of horizontal tangency. And then finally, when theta is 7 pi over 4, we get a fourth and final point of square root 2 over 2, negative 2 for horizontal tangents. So all that's left now will be the vertical tangents. Kind of break it off a little bit here. So for the vertical tangents, it's the same process. We're going to just take these values for theta, toss them back into the parametric equations to get the x and y coordinate. So if theta is 0, we get x is 1 and y is 1. That gives us, or y is 0, so that gives us the point 1, 0. And finally, if theta is pi, we get x is -1 and y is 0. So that gives us a second point where there's a vertical tangent. -1, 0. I hope this has helped. I would encourage you to try, I think, number 33 or maybe number 35. It's another one involving trig functions on finding horizontal and vertical tangents. Thanks for watching.